Section 2.8, the product rule. This section is the product rule because you're taking the derivative of a product, a multiplication problem. The rule for it is right here. So with it, you take the derivative of the first piece, leave the second piece, plus leave the first piece, take the derivative of the second piece. And that's it. Now you will find a lot of other people do it in the other order. They do this first, then this. It doesn't really matter because plus, it doesn't matter if you do this part first or this part first. You just have to see that you take the derivative of one, leave the other, and then take the derivative of the other and leave the other without changing it. And there's lots of ways to do it, but this is the one I'm going to go with. So do you see a product here? So we're going to apply this rule. This is F, this is G. So here's how it rolls. What you do is take the derivative of 8 to the x. That would be 8x times ln 8. All right? And then we just leave the log base 8x. You just leave that. All right? Then we put a plus. Then we leave the first piece, which was the 8x, 8 to the x power. And then we take the derivative of the second piece, which is log base 8x, which is 1 over x times ln the base, which is 8. And that would be your answer. There are lots of ways to simplify this. I'm not going to worry about common denominators right now, but I do see a greatest common factor. We got to get used to pulling out greatest common factors on these things. If you look at the top, front and the back piece, do you notice they both have an 8 to the x power? So what I'm going to do here is I'm going to pull this as a greatest common factor out. So here's how my answer is going to be. 8 to the x power comes out as a GCF. That leaves behind the ln 8 times log base 8x. All right? And on the second piece, it leaves behind a 1 over x ln 8. So that is one way to simplify. You could also right here try to get common denominators and so forth, but I'm not going to go that far. I'm okay with simply calling this as simplified. And there are lots of ways to simplify, and there are purposes later when we apply all this. So, next. If g equals this, then g prime pi is what? The slope at pi is what? So, for this one, we have a product rule. This times this. So let's do this. We have, again, this times this. So we take the derivative of the first part, which would be negative 6. Oh, let me take a step back. Let's say g prime x. Let's do the left side first. That would be negative 6x. When you drop it by 1, that would be negative 3. That's the first piece. We're going to leave the cosine x. Plus, we're going to leave the 3x to the negative second. And now we're going to take the derivative of cosine, which is negative sine x. Now, we can simplify this, but it's not really necessary to simplify it, but I'm going to do it anyways just to make it see it better, because what we really want to do in the end is plug in pi. But let's simplify this. First step would be GCFs. What goes into both of these? Well, what I see is they both have a negative. So I'm going to pull a negative out. They both have a 3, and the highest power is an x to the negative second. So I can see they both have that in common. So what's left behind is negative 3 times what gives you negative 6? Hopefully you can see that would be 2. X to the negative second times what gives you this? That would be x to the negative first. And we still have the cosine x left over in the first piece. Plus, why plus? Because it's plus, the negative got taken out already. We took this whole thing out, but we still have a sign. The negative got pulled out already. So we still have sine. So we still have sine of x. So that right there would be a simplified version. Now we could also get rid of the negative powers. But I'm going to leave it like that. Now I'm going to plug in pi. So what would happen if we plugged in pi? So we're going to plug in pi for every x. Now for visual sake, I'm going to actually put it on the bottom now. Okay, remember the x squared goes to the bottom, and I plugged in pi. All right, I have 2 over pi times cosine pi plus sine pi. So again, I put pi for every single x. Any negative powers that went down just to see it a little bit better. Let's see here. So this isn't going to change. These are just kind of pi's here. Cosine pi, sine pi. One of these is 1, one of these is 0. Which one's which? Cosine at pi is -1. Sine at pi is 0. So what I have here is -3 over pi squared times -2 over pi. Now how do you get that? Well, -1 times this, and there's a plus 0. That's going to just disappear. And then the pi stays on the bottom. So now can you multiply tops and bottoms? And my final answer for this looks like -3 times -2 is +6, and pi squared times pi is pi cubed. So my answer to this problem is 6 over pi cubed. And that would be the slope of this function at pi.